Tako Koning is Holland-born and Alberta-raised. He graduated from the University of Alberta in 1971 with a Bachelor's of Science in Geology and with a Bachelor of Arts in Economics in 1981 from the University of Calgary. He began his career in 1971 working for 2 years for Continental Laboratories as a mudlogger/geologist on offshore drilling rigs on the Grand Banks of Newfoundland. He subsequently worked from 1973 to 2002 for Texaco Inc. and thereafter for Tullow Oil and the US/UK consulting firm of Gaffney, Klein and Associates until 2015 when he semi-retired. He lived and worked as a geologist, exploration manager, and VP exploration in Calgary, Indonesia, Nigeria, and Angola, living for 30 years overseas. He joined the Alberta Paleontological Society in 2015 when he returned home to Calgary from Angola.
He continues to work as a semi-retired senior level consulting geologist. He's very active with APS and the Canadian Energy Geoscience Association by giving lots of presentations and leading geological and paleontological field trips. In 2024, Tako was awarded the honorary membership for CEGA for his work.
So it's a real honor for me to be here. About 6 weeks ago, Mona got hold of me and said that we had a speaker who dropped out and asked if I could maybe substitute. So I kind of scraped this together. Yeah, welcome to the Joggins Fossil Cliffs, the best place in the world to see fossils that show the diversity of the coal age. So more than 300 million years ago, Joggins was home to giant insects, towering trees, and the first known reptiles. But just a couple of comments before I get into it. So they have actually found 215 species of fossilized animals and plants at Joggins, all Carboniferous in age. If anybody want a copy of my PowerPoint, you're welcome to have it. Come see me afterwards. I mean, obviously, there's nothing confidential in here. And just a historic fact that this area was subjected to coal mining because there's a lot of coal out here. And so in 1965, those of you who were here at that time, they had that Spring Hill mine disaster, which resulted in the death of about 75 coal miners, okay? And so just a little history of this area. It's located you can see that red dot up there, and that is at the very northeast corner of the Bay of Fundy. And so they have massive tides going through there, and we'll get more into that. You can drive from Halifax. Halifax is just along that south coast. It's about a 2.5 hour drive from Halifax. So if you should be flying into the area, you can rent a car and drive to Joggins, and then just north of Joggins, you're in New Brunswick. So this is kind of the welcome sign to Joggins. Yours truly standing here. Again, the sign says, welcome to Joggins. Our backyard is 300 million years old. So these are old rocks, okay? In comparison, dinosaurs, whatnot, are in the Jurassic Cretaceous. So they're up at 150 to maybe 60 million years old, but these are 300 million years old. To be perfectly honest, I only spent a day there. In fact, I just spent an afternoon there. So I am not an expert on this whatsoever. But the idea is just to give you kind of an overview what this is all about. I list 5 different publications where I got this information from. I bought everything I could about Joggins, and they have a fantastic interpretive center. And so a lot of the stuff which I'll be showing was taken from there. So what I want to do is give full credit to these publications and also the information which I took from the interpretive center. Now, it's a UNESCO World Heritage Site. Just a statement of outstanding universal value. The Joggins Fossil Cliffs have been inscribed upon the World Heritage List of. The inscription confirms the outstanding universal value of a cultural or natural property which deserves protection for the benefit of humanity. That was awarded to Joggins in 2008. This is the interpretive center, and it looks pretty austere, of course. But we were there kind of late in the afternoon, not many people. It was in early April. And in the summertime, this place is overrun with visitors. But we were there, like I say, April. it's a really well done facility. These are the cliffs. That is looking north, to the left, south, going this way. And so the oldest rocks are in the north. And as you go further south, you go into progressively younger rocks. So you go from the Mississippian and then into the Pennsylvanian. And the rocks which have the most coal are the Pennsylvanian. And very humid. The climate became very humid in the Pennsylvanian and was very conducive to growth of trees. And that's why this area became of great interest for coal mining. I mean, this is before the time of oil. Coal mining was that's what brought people's attention here. So to get there, you go from the interpretive center, you walk down these stairs, and then that puts you right on the beach. They warn you that you don't want to be on the beach when the tide starts to come in, because the tide is the tidal bore is as high as 60 feet. Okay, so 60 feet it's like a 6-story building. Okay, with each floor being 10 feet, and so you can imagine that, and it comes fast. So you don't want to be carried away looking at fossils with that tide coming in, because it could be fatal. And I think giving up your life for fossils is not worth it. This is along the beach. You're looking north to New Brunswick. It's very narrow here. They do offer tours. This is my wife and daughter are the ones to the left, and they're in the audience here. Thanks for coming. Again, a bit of a guided tour. That beach is just chock-a-block full of fossils. I mean, look, I picked this up in no time flat. This is some sort of a branch of some kind of a tree. And like I say, I'm not an expert on this, so I can't quite yet tell you what the species is. But again, here's another thing I picked up on the beach. So this is a tree trunk. This is a tree trunk. And I just stumbled onto it. You can see it's about it's about 1 meter in diameter. And those trees grew up at a height of 30 meters. So you can imagine you got a 3-foot trunk, and these things went up 100 feet. So that's like a 10-story building. So the life in Joggins must have been incredibly interesting and exotic. And I wish I would have had the opportunity to have been there, but obviously that wasn't possible. But then again, this illustrates, you see this stuff everywhere on the beach. Because the tide keeps going in and it's got so much velocity, it keeps eroding. So you get all this landslip. Every year you get new fossils because of the landslip. You could map this almost in 4D. You can map it in 3D, kind of from down and to the sides, but also 4D in terms of time. So because it keeps changing. This is a channel. You can see how it kind of scoured out over here and then infilled with other sediments. The point being that it was some kind of land channel, and it was infilled with sandstones and conglomerates. Remind you, this is a terrestrial environment. It's not marine, it's terrestrial. Although there is a marine component, but which makes up about 10%, but it predominantly, Joggins is all about terrestrial. This coal, this is an example of a coal. You can see how it's kind of weathering gives it this kind of orange color. And then again, more in the coal. They were mining coal here for about 400 years. That's what brought people here to begin with, the coal, because that was the only energy source at that time, going back in the 1500s. Joggins, again, is world famous, fossils rich location. Its importance was recognized already in the early 1800s. And they had famous geologists like Sir Charles Lyell, Sir William Dawson, Logan, and Charles Darwin took a big interest. Charles Darwin never went here, but he did see what was written about it. And so he talks about that in some of his publications. Joggins has been called the Coal Age Galapagos, with reference to the Galapagos Island. It's the world's most complete record of terrestrial life during Carboniferous. And again, because of these powerful tides from the Bay of Fundy, they erode the rock face, so new fossils fall out every year. Like I say, going about the tides are the highest tides in the world, up to 53 feet high, never-ending erosion. So it gives you kind of a 3D or 4D view of it. And so consequently, Joggins is viewed as the world's most important and unique place to study this long vanished ecosystem because it's no longer around. The whole ecosystem went extinct over time. So geologists separate the Carboniferous into the Mississippian and the Pennsylvanian. The Mississippian is lower, the Pennsylvania is higher. Because of the collision of Africa and North America, the uplift of the Appalachians, and that seemed to create very moist conditions. And with those moist conditions, it led to all this growth of plants and trees. The person who did most initial work was William Logan. In fact, Mount Logan was named after him. This is Mr. Logan, and it shows a tree trunk which he mapped. But he was there primarily for the coal. He was the first director for the Geological Survey of Canada. He spent a field season studying the coal beds. And he was hoping that to build an understanding of the coal beds, then he could take that knowledge and extrapolate it and try to find coal in other parts of Ontario and other parts of Canada. And so Logan became one of Canada's most honored scientists, and that's why Mount Logan was named after him. Sir Charles Lyell, a very famous British geologist, he got interested, and so he spent time out there also. But especially a guy called William Dawson, he became a famous geologist, although Dawson Creek was not named after him. The miners, they would provide them with dynamite in order to blow up some of it just to help to expose the trees. Anyway, so there was a lot of cooperation between the coal miners and the paleontologists. And again, there's a century of coal mining that went on till the 1960s, especially during the war, World War I and World War II, especially World War X, when coal was so important as a source of energy. This area was really, really intense with coal. But already, this was from the International Geological Congress. They met here about 1906 because already it was famous. And this shows the visitors from all over the world, and they're sitting down having lunch. And you can see some of those guys, they're field geologists, but they're all wearing nice hats and ties, right? You can see them all wearing ties because they're kind of formal. But still, already by that time, it was famous. It's famous because of its record of life on land, all sorts of creatures, big and small. They have these towering trees, which are 100 feet high, but the spores also, which you can see by microscope. This is an example of one of these trees. It's a lycopodiid tree. They grew where they stayed rooted, where they grew. In other words, you can see the sediments come adjacent to it. So these trees didn't fall over. And that's what makes it so interesting. These trees stayed vertical. And so you can see those beds, they're perpendicular to the tree trunk. This is an example of the cliff. When you're at the north, the rock are age of about 325 million. And then at the south end, they're about 310 million. Because as you go along here progressively from the north to the south, you keep going into younger beds. That's why they say it's a 15 million year walk as you walk along these cliffs. Sir Dawson called this the grand exposure. He said a spectacular sight, but with all the shoreline, sometimes was calling terrible landslips. With these landslips, of course, they continued to reveal new fossils and lead to new discoveries. Life in the coal age, so it would have been a tropical valley near the equator. You had huge forests of strange trees and lush ferns. And apparently the oxygen level was the highest ever that the Earth has ever known. And then all these trees were sometimes falling over and leaving a spongy peat, which became coal. And then you had very bizarre fish, and you had also giant dragonflies, some of which were fossilized. You had primitive tetrapods, which were four-legged amphibians and reptiles. And it is supposed to be the best place on Earth to study this long-vanished ecosystem. So this is a diorama, and it just shows what it was like. You know, you can see this river flowing through here, lots of trees, lots of bugs. Here's another view, again, a lake associated with it. This is, again, an artist's rendition of fish, a huge amount of different freshwater fish. And I won't, in the interest of time, I won't mention the names of them, although there's one, number 8 here at the bottom. It's called the coelacanth, which is quite an interesting fish. This is taken from the Interpretive Center, but just up to the left is a scales And then the rest are the vertebrae from this fish. Joggins is famous for this fish. This again shows the lush life. This was called a jumping spider off to the left. Apparently, these spiders were like they're twice the size of your hand. If you're living at that time and to hang around this environment would have been a little scary. Here's one of these trees, a sigillera, which I'll just talk about briefly. The sigillera was the most common tree. It dropped all sorts of spores throughout its life. And so then those spores would create new life. And then, of course, branches fall off. And so you'd have beneath these trees, you have a whole layer of organic stuff. And that eventually became coal. That became coal. The reason's still not understood. That whole system collapsed into extinction. This is an example of some of these branches, these tree branches. I took the photo at the Interpretive Center. This is a tree trunk, and then they sampled along the edge of it. In some cases, these tree trunks were hollow, and people like Dawson and Lyle, they found all sorts of fossilized reptiles and amphibians inside the tree trunk. So a very exotic situation, to say the least. With the way these trees grew, this would have been the start of a tree, a pithy interior, hollow, often where they were hollow inside. And then to the left, parts of the tree trunk would fall off. Then you had more sediment coming up, essentially burying the tree. And then the third one now is fully buried, it's full of sand and mud, and that preserves the tree. And then the bark slowly turns to coal. And that's why this area became so prospective for coal. Well, slowly, I'm almost finished. But you had all these trace fossils also. And of course, the trace fossils show important clues about how animals moved and back and forth. This is from some sort of a amphibian. You can see it would have been left leg, right leg, even though the fossils, the chance of it being fossilized is rare. But in terms of fossil tracks, they preserve easily, so there's an abundance of trace fossils at Joggins. This is the top predator in the coal age, and it was found by Dawson in 1863. It was about 2 meters long, and so you can see how they reconstructed putting the legs in. These critters were nothing compared to what you had in Drumheller, for example. By that time, these critters had evolved into mega creatures like the T-Rex. But this was the start of, reptiles and amphibians. Again, a trackway. This is really stunning to me. So you can see all those little tracks. You can see they all have 4 whatever, and they're kind of wandering all over the place as this amphibian creature was kind of wandering just along the shoreline of the sea or along the shoreline of a stream or river. So winding down, primitive tetrapods hunt insects and other invertebrates on land. So that was Joggins during the late Carboniferous. It's supposed to be the best place in the earth to study this long vanished ecosystem. Conclusions, it's the best place in the world to study Carboniferous. It's just 2.5 hours from Halifax. It's a 200-kilometer drive. The countryside there is beautiful, peaceful, rural Nova Scotia. So if you were to do some touring in the Maritimes, it would be a perfect way to add some, add to your trip. And then there's other museums in the area. The Nova Scotians really have done a great job with some interpretive centers. And then there's beautiful valleys and apple orchards and the whole works. Thank you. Any questions? There's got to be questions.
Kathleen, I'm going to be giving the next talk. I just really enjoy hearing about Pennsylvanian fossils because I first started working with Pennsylvanian fossils in Ohio and Kentucky in what are called coal balls that are anatomically preserved. But I've never gotten to go to the Joggins locality, but it's really a beautiful locality. I'm really enjoyed your presentation.
Great.
I'm just interested, was it the lack of bacteria that would not let the trees and plants decompose, and that's what actually created the coal?
Boy, yeah, I mean, it's a kind of a curious thing. What caused these trees to grow so high? And then on top of that, they were known to be kind of a hollow inside. And so that kind of growth dynamics, it kind of confuses me. But again, all that organic stuff was raining down from the trees, branches and stuff, forming these coal seams. They were not thick coal seams, but they were like interbedded coal seams. And certainly enough, and they're old. It's Carboniferous, so it's a lignite. It wouldn't be a peat or something. So it would have been high quality coal, and that's why there was so much work done with the coal. I don't know. Dale Leckie. Dale has got interest. What do you think? Any
I
idea?
don't have an answer on it.
Okay.
I'll leave it to you.
Basically, to answer what I can about that, you had an anaerobic environment. So basically, you had this all of the biomass, all the organic was bound up in the biomass, and so you had this. It was basically a big swampy area. And so basically, because it was anaerobic, you didn't have a chance for bacteria and fungi to get in and totally destroy it. Although you do get fossil fungi involved sometimes in these things, in these Pennsylvanian fossils.
I think the trees are basically cast to mold, so there's not that much organic matter.
Yeah, exactly. Yeah, these are mold casts, and the mud fills in. And
I was just commenting that the trees, the vertical trees, are probably mostly a cast or a mold of what was there, and there's not
Yes.
much organic matter at all in the vertical tree trunks. I don't know if this is the right story, but there is a Windsor salt, and there's a lot of subbasins that get very thick in different units in Nova Scotia, and I don't know whether something down dropping that quickly might explain that you actually preserve 30 meters worth of trunk.
Mhm.
You go to Willow Creek in Heller, there, the least of it, you see a couple of meters of trunk, but I don't know anybody gets up to 30 meters. So I think the subsidence was greater if the salt was removed.
Yeah.
Mhm.
And there's also a lot of tectonics going on.
One last comment. The Nova Scotians are exceptionally friendly people, very welcoming. And so, we're now in a situation here in Canada where some of the trips we had planned to make to the United States were putting those kind of on hold because of some of the attitudes towards Canadians in the States. So if you're looking for a destination, instead of going to Florida or someplace, you want to go to someplace very friendly, go to Nova Scotia.
Okay, well, thank you.